Hi, this is Dr. Syed from India. Today I am going to teach you about NEBOSH IGC Element 11 Part 2E Plant Startup and Shutdown Hazards Controls. Presence and removal of water hydrates. The formation of hydrates like ice plugs is a potential problem within a production process plant during startup and shutdown process. This is a potential problem which can create a serious consequences. So we should take more care and precautions to solve this problem. Hydrates are formed when water gets trapped within the oil or gas process and the conditions within the process allow it to freeze and it will convert it into a solid plug. When the flow of the pressure in the pipeline is reduced, the temperature will be reduced, and at this point the formation of a hydrate can generate if there is water within the system. It's also possible that hydrates can also be generated in the pipelines which will run across the seabed. It happens due to the temperatures at seabed level which may be at low temperature and get freeze. How it happens? The unsalted water accompanies the oil when the oil is extracted from the wells. But some hydrates are made up of some other materials, and these will form into sticky crystals which are more potential to grow into large ice plugs, and these plugs can completely block a pipeline. How to control water hydrates? Hydrates forming can be prevented by using the antifreeze methanol or glycol in the process system. In this process, methanol and glycol will become the part of the product. These antifreeze materials can be covered later when the oil and gas comes over onshore, and it's possible to reduce the antifreeze materials. But if you try to reuse the antifreeze materials, it's an expensive process. So an alternative method is the use of trace heaters along with insulation. Here you can see the trace heaters on the pipelines. These trace heaters are the cables which are placed along the outside wall of the pipework, which can warm the pipe wall system. How to remove the water from oil and gas? There are different methods used to remove water from the processed oil and gas. Each method has its own advantage and disadvantages also. The following techniques are used for removing the water from oil and gas. Removal of water by gravity separation method. We can't collect only pure oil from the oil wells. So the oil collected from the oil well is a mixture of oil, water and natural gas. When this mixture is stored in a vessel and allowed to settle down without any movements, the water will naturally settle to the bottom of the vessel as the specific gravity of water is greater than oil. Then this water can be drained off. You are seeing a diagram here, which is the separation of oil, water and gas. In this vessel you can see three layers. One is water layer. Above this water layer, oil layer is there, and above that natural gas is there. So water is collected from the bottom pipe and oil is collected at the right side, and it's also collected from another pipe, and the natural gas is collected from the above portion of this vessel. In this gravity separation system, the effectiveness depends upon how long the water is allowed to withstand before water is drained off. It also depends on the temperature at low level. It reduces the saturation point to an acceptable level. The oil collected from the oil well is a mixture of oil, water and gas. In this gravity separation method, lowering the saturation point can ensure as much of water as possible can leave the system. But some types of oils have the characteristics of holding water in suspension rather than allowing it to settle at the bottom and separate it out. In this situation, gravity separation system is a less effective option. The advantage of this system is low cost of operation, and the disadvantage is that it removes only free water, but it leaves off the emulsified water in the vessel. There are different methods are used in oil and water separations. One of the method is oil separation by centrifugal system. This system works on the principles of centrifugal force, and in fact the water consists of a different specific gravity compared to oil. This gravity difference allows the system to separate the two different materials. When the difference in specific gravities between the oil and the water is more, the process will be more effective, as the centrifugal operations can work well on low specific gravity and low viscosity oils. This centrifugal system removes both free water and emulsified water, but their effectiveness will depend on the specific gravity of the oil when the centrifugal process takes place. The more advantage of this system is that we can use this system in the correct and right circumstances. we can remove both the free and emulsified water along with other heavier contaminations. Compared to the other processes, this is a good technological process. In fact, these centrifugal separators are cost effective. But the main disadvantage of this system is that the capital investment is relatively high. The another disadvantage of this process is cleaning a centrifugal system is a time consuming which has to be undertaken more frequently. Water or moisture removal process. Water or moisture removal process is a technique where we use filters to absorb the moisture from the product. This process is a continuous process where the product passes through the filter, the water or moisture is removed from the product. There are different types of filter mediums which are used in this process. The cellulose-based filters are more effective for the removing of small amounts of water. In the polymer-based filters, we can notice the swelling of the filter when they get absorbed the moisture from the product. The size of swelling the filter indicates that it absorbed the presence of water in the product. The other types of filters consist of a polymer outer wrapping and desiccants which will absorb both free water and emulsified water, and they can filter out the solids. This process is a relatively most cost effective in removing small amount of water. But one of the disadvantages is that each filter has a limited capacity of usage. Now another method is vacuum dehydration. Vacuum dehydration works on the principles of water boils at a lower temperature and at a lower pressure. A vacuum dehydration unit helps to reduce the inside pressure of the product. The warmed dry air is then passed over the product and the moisture is then transferred to the air in the form of steam vapor. The surface area of the product can increase the efficiency of the system if it's exposed to the warm air. And this can be achieved by exposing the surface of the product within the dehydrator. The advantage of this system is it can remove moisture to very low levels. It can also remove the other impurities such as fuels and solvents. But the disadvantage of this system is its cost and low flow rates. The another method is air stripping. Air stripping is another type of vacuum dehydrator in which air or nitrogen gas is mixed with a stream of heated product within the air stripping unit. Then the gas absorbs the moisture from the product. When this gas and product mixture is expanded, the gas will separate it from the product along with the moisture, and thus the moisture is removed. In the system, it have both advantages and disadvantages. The advantage of this system is that it costs less to maintain than a typical vacuum dehydrator. And the disadvantage are its cost and low flow rates. The another method is natural evaporation. Some processes run at elevated temperatures. This process doesn't require any other process to remove moisture or water. These processes are self-sufficient to evaporate the water at these temperatures. But we should be very careful and control the process effectively to avoid harm, particularly with mineral oils. Compared to centrifugal and vacuum separation system, heating the oil can be an effective means of removing water from a product. So finally, this is the summary. The best system of water removal depends on the following factors: the capacity and the volume of the product to be treated, how much of moisture content is required in the final product. If the level of moisture required in the final product is low, but the saturation level of the product prior to the treatment is high, this system is more complex and expensive. Now we will discuss about testing, commissioning and hookup hazards. We will take commissioning in the beginning. The commissioning process involves various tests and inspection of the plant before it starts production. The reason of these tests are to determine that the system will function well with safety. Prior to the commissioning of the plant, all the personnel involved in this process and control room operators are provided with proper training. Before commissioning the plant, an important document called operating procedures are prepared for the guidance purpose and for not to do any mistakes. If any mistakes happens during the commissioning process, the possibility of unforeseen events may occur which can't be eliminated. Hence, all the safety precautions should be reviewed before commissioning the process. All the safety precautions are identified at the design stage of the plant and called as hazard and operability, HAZOP study, or risk and assessment. The process of commissioning involves taking the plant through a number of phases, and all of which have to be completed in a satisfactory manner before the plant can be handed over as fully functional and ready for operational purpose. During the commissioning process, the following inspections are carried out sequentially. Number one, configuration of the system is inspected physically. Number two, the pipework and system integrity is inspected. Then the complete instrumentation system is inspected thoroughly. Then all the security alarms are inspected to confirm their working conditions. Then finally all the storage and processing vessels and pipelines are flushed and cleaned well. But still you need to confirm all the ancillary equipment is inspected to confirm their working conditions. All the instruments connected to vessels and pipelines are thoroughly calibrated. The protocols for the startup or commissioning and shutdown is well established. Then take the trials of commissioning and startup to confirm that the protocols are correctly established. Then the plant should be hooked up and then handed over to the concerned department. Now we will discuss about the commissioning process in detail. Before commissioning, we should thoroughly check up the system physically over the line. In this phase, we check up all the pipework and connected instrumentation. Everything is physically inspected to ensure their correct configuration and installations as per the system requirements, that is, engineering line diagrams. Thus, this inspection process can confirm and ensure that the plant and equipment are clean, empty, and fit for the purpose. Now we will discuss about pipework and system integrity. In this phase, all the parts of the systems are tested with pressure tests to ensure that there are no leaks or unexpected deformities. This testing is called hydrostatic testing. Hydrostatic testing is a system which tests the integrity of the plant, equipment, and pipelines. In this testing, the testing pressure will be raised to more than 1.5 of the normal working pressure. But it depends upon the piping system, like low pressure or high pressure piping system. In this hydrostatic testing, water filling is done in individual sections or components of the system, usually with dyed water. And then that section or component is pressurized. Then the pressure is monitored to observe that if there is any unexpected deformity or loss of pressure. A loss of pressure indicates that somewhere water is leaking. All the sections and components will be tested individually, and again all the sections are connected together. And again a pressure test is carried out along with the flanged joints and couplings with the nitrogen gas. In this test, we can test out and detect any available gas leaks. Now we will discuss about the commissioning of instrumentation. Instrumentation commissioning is carried out as per the piping and instrumentation diagrams, P and IDs. A P and ID is a schematic diagram which shows the physical sequence of equipment that how it is connected. P and Is consist of the following details: the location and the designation of all the instruments, mechanical equipment with their names, numbers and functions. P and ID can show you all the valves with their identification and function. It also shows you all the piping with their sizes and identification, and any miscellaneous equipment such as vents, drains, sampling lines, startup and flush lines, etc. The direction of flow and any interconnection references, all control input, outputs and interlocks, all computer control system inputs, any identification references of components and subsystems delivered by these third parties. Now we'll discuss about the commissioning of alarms. Settings of all the alarms, microprocessors, signals, hardware trips and all the other instruments are inspected perfectly to ensure the settings are correct and are functioning well. The information system and computers are checked to ensure that they are functioning well, and the information collected from all the field instruments is being displayed correctly. Now we'll discuss about the commissioning of pipelines and vessels. In this phase of commissioning, all the vessels and associate pipelines are cleaned and flushed thoroughly with water to confirm that the equipment is very clean without any foreign materials, which may be laying in at the time of construction or repair. After the flushing operations, it's necessary to dry the system completely. If the final process system is incompatible with water, then it is done by venting warm, dry air so that any residual moisture can be evaporated away. Commissioning of all the vessels, ancillary equipment and instruments. In this activity, all the vessels, instruments, ancillary equipment like pumps, fans, condensers, compressors, heat exchangers, etc. are inspected to ensure that they perform as per our standard requirements. A standard calibration of the instruments is carried out to ensure a standard testing. Commissioning and startup. The commissioning and startup is a written procedure which we should follow very strictly. This procedure can guide us from complete shutdown to full production. This procedure includes the establishment of all the potential wrong occurrences and also provide the best and safest guidance to take action on how to deal with each of them. Commissioning and a startup. The startup procedure is also a part of the operating procedure document. This phase will also involve the training of all personnel involved in the operation of the system once it is handed over. Shutdown procedure. In this procedure, the complete shutdown procedure starting from the full production to complete shutdown is implemented and a complete procedure is documented. This procedure also includes the establishment of guidelines and safe practice for all the possible potential errors which may occur in the shutdown procedure. Hence, this shutdown procedure will be considered as the part of the operating procedure and also considered as training document for the employees. Commissioning procedure and the trials. In this procedure, the plant is started up and continued to run for a predetermined length of time with specific parameters and then shut down. By this trial, we can decide that the plant can be operated well without any problems. In this trial, we can give hands-on training to the personnel who will operating the plant. Commissioning and handover procedure. This is the final action of the commissioning process, where it involves the handing over of the plant and its responsibilities to the operation department. All the related documents, procedures, and drawings are handed over. In this trial commissioning of the plant, all the representatives of the suppliers of the plant and equipment will be present on site to see the performance of their products. My dear students, this is the end of NEBOSH IGC Element 11 Part E. Plant Startup and Shutdown Hazards Controls. Work safely, live safely. Thanking you very much.